Hello there, ladies and gentlemen. Today we're going to be talking about inverse functions, what they are, how we can find them, what we're talking about here. So, inverse functions. Okay, inverse functions are functions that are, we could kind of consider them the opposite of each other. Okay, really what they do is that they kind of undo each other. When you plug them into each other, they kind of undo each other. All right. The main thing, if we're talking about graphically, what happens is that the domain of your one function becomes the range of its inverse and vice versa, okay? So basically, it's what happens when we flip-flop the domain and range of our functions, okay? That creates the inverse functions that we're going to be talking about, okay? Now, graphically, we can figure out if a function has an inverse based off something called it being one-to-one, okay? A function has an inverse function if it is one-to-one, which means that every y value only has one x value. Now, that definition should kind of sound a little bit familiar. It sounds very similar to our definition for functions, okay? For a function, we say every x can only have one y. Now we're saying the opposite. For it to be one-to-one, every y can only have one x, okay? And the way we're actually going to see if a function has an inverse or not is actually based off of the horizontal line test. Wait, did we learn about this before? No, we've actually learned about the vertical line test, the way we figure out if you have a function or not. To figure out if it has an inverse function, you do the horizontal line test. So here is a function, y equals x squared, okay? Y equals x squared is a function we talked about a lot. It passes the vertical line test. I can draw a vertical line, won't touch it more than one spot. However, it does not pass the horizontal line test. I can draw a horizontal line right there that touches my graph in two places. That means that this function does not have an inverse function. Now, I could find an inverse function by limiting the domain of my original function, and then I can find kind of a partial inverse, okay? So for example, if I think about this parabola, what if I just cut off its domain right here and I said, hey, what about from 0 out to infinity? Then I would, in fact, have an inverse. That would pass the horizontal line test, and I could find an inverse function for that domain. Same thing for the less than 0. I could also find an inverse function for that portion of the domain as well. So we can limit the domain to find our inverse functions, but in general, we do the horizontal line test. If it touches more than once, it does not have an inverse. Okay? How we find an inverse algebraically. So if we have a function and we say, hey, we know that it's one-to-one, we know that it has an inverse, we can find the inverse by doing this method. Basically what we're going to do is that we first have to prove it's one-to-one. So either horizontal line test, we're not really going to focus too much on the proving it's one-to-one. I'm going to kind of be like, hey, this is going to be one-to-one. But then what we're going to do is we're going to rewrite into an equation form. So basically we're going to take f of x, the function notation, replace it with y because it makes the rest of this process a little bit cleaner and easier. You then switch the x and y, and you solve for y, okay? And that'll give you what the inverse function would be, okay? So for example, if I have 5 minus 3x over 2, we're just going to, again, we could graph this and look at it, but we're just going to say, okay, this has an inverse. Let's figure out what it is. So we're going to set it equal to y. So we're going to say, all right, y equals 5 minus 3x over 2. We're then going to go ahead and we're going to flip-flop the y and the x. We're going to say x equals 5 minus 3y over 2. So we flip the x and y, and now we solve for y to tell us what that inverse function is. So to solve for y, I multiply both sides by 2. I get that 2x equals 5 minus 3y. I then go ahead and subtract 5. 2x minus 5 equals negative 3y. And then I'll go ahead and divide by negative 3. And so I'll get that y has to equal negative 2/3 x plus 5/3. And this would be the inverse function for this function up here. Okay? These would be the functions that we would consider being opposites of each other. We'll see in a second they will undo each other, okay? And the domain of the one is the range of the other and vice versa, okay? Here's another one. This time we have the cube root of x plus 1, and I want to figure out what its inverse function is. So again, I'll start by writing this equal to y. So y equals the cube root of x plus 1. I'll flip-flop my x and y. So we're going to get that x equals the cube root of y plus 1. And then I solve for y, and that'll get me the inverse. So to get rid of this cube root, I'm going to cube both sides. I get that x cubed equals y plus 1. Subtract 1 from each side. I get that y equals x cubed minus 1. So this would be the inverse function right there for g. Now, the notation we're going to use for the inverse function, if I get an inverse function, we're actually going to write it like this. It's g, and we put a little -1 over there. That's telling you that you're talking about the inverse function, okay? It's a way in our function notation for us to label it so that we can show to somebody when they see these two functions next to each other, oh yeah, this function, they're inverses. This is g's inverse, okay? All right, now, another thing that we can do, and actually this is a better definition for really what it means to be an inverse. Earlier we said like they're opposites of each other, they undo each other. This is mathematically what's really going on, is that when you compose them together, a function and its inverse, you actually will end up with x. And that's for both directions. Whether you do f of g of x or g of f of x, when you compose them together, you should end up with just x, okay? If that happens, you have two functions that are inverses of each other, okay? They're undoing each other and giving you just x left over, okay? And again, as I said earlier, we're going to use f and this little -1. Okay, that's going to be kind of our main notation when we're talking about inverse functions. That way we can say, hey, here's your inverse, a little -1. That's what that's going to mean in this context, okay? So here's an example. I have two functions. I have 5 over x minus 2, and I have 5 over x plus 2. And I want to know, hey, are these two functions, are they inverses? Okay, are these two functions inverses? And the way I would figure that out is by composing them together. So I would do f of g of x, so fog, and I also would do g of f of x, or gof. And I want to make sure that I end up with just x when I do that composition. So f of g of x would be 5 over x plus 2 minus 2. Okay? And so to simplify this, plus 2 minus 2 is going to be 0. So I'm going to get 5 over x. Here we are dividing by a fraction. We're dividing by 5 over x. That's the same thing as multiplying by its reciprocal. So really this is the same thing as 5 times x over 5, which gives me x. Okay, so that direction I got x. That's leaning me towards that these are inverses. But I have to check it the other direction as well. So I'm going to do g of f of x, where I'm going to plug f of x into the g function. So in this one, it's going to be 5 over x minus 2 plus 2. And again, dividing by a fraction, the same thing as multiplying by its reciprocal. So this is really 5 times x minus 2 over 5. Those 5's will cancel. I'm going to get x minus 2 plus 2, which will equal x. I got x from both ways that I composed that, therefore these are inverses of each other, okay? I compose them this way, I got this. If I compose them this way, I got x. That means that these are going to be inverses based off of that composition, okay? So that's really it. That's the main thing about inverse functions. You compose them together, you should get x. If you want to find the inverse, you flip-flop your x and y, and then you solve for y and see that's going to be your resulting function, okay? So inverse functions, when you compose them together, they undo each other, and then that's how we find them, okay? Thank you all for watching.